Human and Social Dimensions of Climate Change. This course is brought to you by Gilad James Mystery School. Learn more at giladjames.com. Introduction. Climate change is one of the most pressing and complex problems facing humanity. Climate change was first presented as a biophysical phenomenon, one that would manifest itself through sea level rise, melting polar ice caps, and warming temperatures. It has since become an issue of international significance and the subject of ongoing dialogue in both political and academic settings. As the risks of climate change deepen, so too does the contention and confusion surrounding how best to proceed. How we address climate change is continuously redefined and expanded in academia and policy. As the focus has gradually shifted from mitigation to adaptation, the dialogue has shifted to include the social dimensions of climate change, resulting in a sharp rise in research on the human dimensions of climate change. No longer just a biophysical phenomena, climate change has become a lens through which we analyze poverty, inequality, vulnerability, and development. It has created intense debate about who is responsible, who is most susceptible, and how best to prepare for the consequences of a changing climate. To address these questions, climate change scholarship has developed the concepts of vulnerability and adaptation. The rise in vulnerability and adaptation research has been accompanied by an increase in methodological frameworks and theoretical approaches to understand and assess vulnerability and design and implement appropriate adaptation strategies. Through this work, it has become increasingly apparent that vulnerability to the various threats posed by climate change is not just a function of the threats themselves, but is shaped by the cultural, institutional, and socioeconomic contexts in which these risks occur. Similarly, the capacity to adapt to climate change is influenced by the very same factors. Much of the scholarship on vulnerability and adaptation has focused on those most vulnerable to the impacts of climate change, particularly resource-dependent, agricultural societies. Food production is of fundamental importance to the global community, and many agricultural societies will undeniably need to adapt to new biophysical conditions in order to persist. The livelihoods of resource-dependent farmers are inextricably linked to their biophysical environments, and there is a great need to understand these relationships to better inform adaptation options. Within the context of resource-dependent agriculture, institutions and technology have been identified as two factors that shape both vulnerability and the capacity to adapt. To understand how innovation in both institutions and technology can be used to address climate change, the South American country of Peru will serve as a case study and the backdrop to a discussion on the dynamics between vulnerability, adaptation, institutions, and technology. This lecture will focus on the Peruvian Highlands, an expansive steppe characterized by vast mountain ranges, tropical glaciers, and indigenous, resource-dependent agricultural communities. Peru's highlands cover a little over 30% of the country and yet contain over 70% of the world's tropical glaciers. Runoff from these glaciers forms the life support system for highland agriculture and for urban consumption in swelling coastal cities such as Lima. Warming temperatures and more variable precipitation have led to accelerated melting, with far-reaching implications for agriculture, industry, and urban users. The region is also undergoing considerable socioeconomic changes, as population growth has increased the need for agriculture, mining, and recreation, changing the nature of traditionally rural, subsistence landscapes. In the last several decades, the role of environmental and humanitarian NGOs in climate change adaptation has become far more pronounced in the region. Often, these NGOs provide resources, assistance, and in some cases, technologies to farmers. They are a part of an emerging network of climate change practitioners focused on preserving the agricultural and cultural traditions of highland communities. In these communities, traditional, pre-Hispanic agricultural technologies are being revived and in some cases combined with modern technologies to create innovative adaptation efforts. This lecture will illustrate the dynamics between institutions, technology, and local-scale adaptation efforts. It will present a background on the past, current, and projected changes in the region's glaciers and climate. It will discuss how these changes will impact local communities, and will explore the various methods communities are using in response to these impacts. It will review important theoretical concepts such as vulnerability, adaptive capacity, and adaptation. Andean agricultural communities offer an excellent case to examine the role of technology and institutions in shaping adaptation pathways in agricultural communities. In many regions of the world, climate change impacts are already a reality, underscoring the need to understand how communities are impacted and how they are adapting. Tropical glaciers respond quickly to changes in climate and therefore serve as excellent indicators of climate change. Since glaciers are distributed worldwide, they serve as an exemplar of global climatic conditions. Many of the world's glaciers are in close proximity to settlements, causing the effects of climate change to be readily observed by communities. Additionally, alpine glaciers are oftentimes connected to environmental, social, and economic dimensions of communities in surrounding lowlands. Consequently, any changes to mountain glaciers have immediate and significant impacts on populations. This is especially true in Peru, where glaciers and the water they provide are intimately associated with indigenous culture, customs, and religion. In regions where glaciers provide an important source of freshwater, there is growing concern regarding how climate change may alter the relationship between alpine glaciers and freshwater availability. There has been rapid and accelerating recession of mountain glaciers worldwide during the last 50 years, with increasing concern for potential environmental, economic, social, and political implications should these trends continue. Andean glaciers have displayed continued recession, with the most pronounced retreats beginning in the early 1980s. Many of these glaciers have been in existence for centuries, yet they exhibit some of the most rapid mass and surface area losses in the world. Scientists project serious implications in the future if atmospheric warming continues. The Cordillera Blanca is part of the Peruvian Andes and is the country's largest and most northerly mountain range, covering over 130 kilometers between 8 degrees and 10 degrees south latitude. More than 99% of all the world's tropical glaciers are located in the South American Andes, and roughly 70% of these are found in Peru alone. The Cordillera Blanca is Peru's most extensively glaciated mountain range, with a quarter of the world's tropical glaciers in glacial valleys with elevations ranging from 3,000 to 6,800 meters. The range contains approximately 722 glaciers covering more than 723 square kilometers. Similar to the global trends, considerable glacier retreat has been documented in the Cordillera Blanca over the 20th century. Studies indicate that the Cordillera Blanca has lost over 25% of its coverage since 1970, during which, the average temperature has increased 0.35 degrees Celsius to 0.39 degrees Celsius per decade. Persistent and accelerated glacial shrinkage in the Cordillera Blanca is anticipated for the future, with severe consequences for the region's water supply and those who depend on it. The Cordillera Blanca's glaciers provide the fundamental water source for irrigated agriculture, domestic livestock, human consumption, and hydropower generation in the region. The region's dependence on this resource will invite serious implications in decades to come as scientists expect atmospheric warming to continue to accelerate. Additionally, increased melting causes the formation of glacier lakes at the glacier terminus. These lakes become dammed by unsorted till deposited by the retreating glaciers, leaving nearby developments at risk for glacier lake outburst floods, GLOFs. Consequently, accelerated melting in the region is of great concern as it poses a threat to the local water resource and increases in the risk of GLOFs associated with moraine dammed lakes. In the tropics and extratropics, moisture availability is governed by the oscillation of the intertropical convergence zone, which creates variations in the amount of moisture received. The climate of the Cordillera Blanca region features low thermal seasonality with an average annual temperature range from 0 degrees Celsius to 9 degrees Celsius, while diurnal variations in temperature are typically greater. In alpine areas, the steep topography also creates a steep temperature gradient. Monthly precipitation displays significant seasonality with the most precipitation falling during the wet season occurring between October and April. More than 80% of precipitation falls during the wet season, resulting in higher stream discharge during those months. Glacier mass accumulation occurs during the wet season while ablation, mass loss through evaporation and melting, can occur year-round.